And C is minus 7. Let me say that. C is minus 7. You have to include the negative sign. Okay, that's great. That's awesome. So what A times C then we get is what? 6 times negative 7, which is minus 42. And B we get is 1. So by our process, what are we saying? We want two numbers whose product is minus 42 and the sum is 1. And again, it's tempting to use 6 and negative 7, but the problem with that is 6 plus negative 7 is negative 1. What about 7 and negative 6, though, down here? That will work. And how do I know that? 7 times negative 6 is negative 42, and the sum of 7 and negative 6 is 1. So these are going to work. All right, that's great. So 7 plus negative 6 is what we're going to use. So we're going to replace the coefficient of x, our b, with this sum. Okay, so let's do that. So 6x squared plus, remember, we got to use parentheses, right? We have to use parentheses here. We have negative 6 plus 7 times x. Okay, the 1 is here. It's not written, but it's there. So we have negative 6 plus 7 times x minus 7. And then what do we do next? Well, first I get this PowerPoint pen. We distribute. Oh, come on. There we go. Beautiful, beautiful. There we go. Like so. We distribute, and that's how we get the next step. And now we use factor by grouping. That's what we're going to use. And again, I mean, when you first start this, if you did skip finding the GCF here of this thing, that's actually okay. I mean, that's what I did here. So notice also, I mean, I didn't do this with the solutions in the worksheet, but notice that we have excuse me. Sorry, I got ahead of myself. Notice that we have addition between the second, the third, and fourth term, right? That's what we want. We always want to make sure we have addition there. So let me say it again. We have addition between the second and third term. That's what we want here. Okay? Good. Okay, so now let's factor each group. 6x squared minus 6 times x, right? Well, again, let's find the GCF. So the smallest exponent of x, right? That's just 1. Okay, so that's 1. So that's our m, excuse me. Also, notice the coefficients here, they're both equal to 6. So clearly, that's, well, hopefully it's easy to see then, that forces b to equal 6. Right? The coefficients are both equal to each other. They're both equal to 6. So the greatest common factor then of the coefficients has to be 6. Okay? So what we get is the GCF here happens to be 6 times x to the first, which is just 6 times x. So what do? Factor it out like so. Right? We factor, that means we put it in front. We divide to see what's left over, meaning we divide into each term. And what happens when you do that? Well, let's take a look. Here in the first quotient, you can see the 6's are going to cancel. You get x squared over x, which is just x itself. Here, 6x cancels with itself. Something divided by itself, you get 1. So we get 6 times x minus 1. That's fun. Okay, now that's the first group. Okay, let's handle the second group. The 7x minus 7. Well, since there's a non-zero constant term, right, the smallest exponent of x then has to be 0. The smallest exponent of x then has to be 0. Again, there's a non-zero constant term. Also, the coefficient and the constant term, they're equal to each other. They're both 7. So the greatest common factor of the coefficient and the constant term is 7. So b is 7. B is the greatest common factor of the coefficient and the constant term. M is the smallest exponent of x, which is 0. So we get 7x to the 0, which we can take as 7. And of course, now we can just factor it out. So when you factor it out, I mean, here you could probably get away with skipping these steps because it's easy to see what's going to happen, right? When you put the 7 out, when you put 7 in front, you have to take 7 away from what's in parentheses. But again, you can just divide, which means you divide into each term. Let me show the work though. So here we get 7. The 7's cancel, right? So you're just left with x. Here, these cancel, and you get 1. So that's what happens here. All right, that's good. So altogether, right? Altogether, from the first group when we factored it, right? We got 6 times x, 6x times x minus 1. Here. For the second group we just did, 7 times x minus 1. As you can see. So we have x minus 1. We have the same thing here in parentheses. That's good. When you do factor by grouping, that's what you want. So let's take it out in front. Bring it out in front. You're left with 6x from the first product. Here we're left with 7. So altogether, we get x minus 1 times 6x plus 7. And that's what we get. Okay, and again, I know some students like to see all the work. So that's what I did here. Again, you don't have to show these steps here. You wouldn't have to show on an exam. For this part of the problem, you could just do this. But here I like to show them all so that, because certain people like to see all the steps, certain students. I mean, based on my past experience teaching, that's what I've seen. So you put the x minus 1 out in front, you have to divide to see what's left over, which means you divide into each term. And when you do that, this cancels with this, as you can see. This cancels with this. So you're left with 6x plus 7. And that's our answer. Good. Now, what questions do you have about this? Okay. So I figured I'd do one more after I do these vocabulary, and we might get to one where you can try on your own, but we'll see. Anyway, this is just vocabulary. I think that's good to know. I mean, I'm not going to do a vocabulary test, although I guess theoretically I could, but I think I won't. Yeah. Basically, remember, when you factor, you can always do what's called the trivial factorization. That's when you write the polynomial as 1 times the polynomial itself, or -1 times the negative of the polynomial. I mean, no matter what the polynomial is, just like with integers, you can always factor that way. You know, because 1 times anything is itself. But that's not really helpful for us, though. That's like, you know, we don't need to learn any factorization techniques to factor this, the trivial factorizations. That's why they're trivial. Also, if this is the only way to factor, then we say the polynomial is irreducible. If the only way you could factor it are the trivial ones. So again, for any polynomial, you can always factor it as 1 times the polynomial, or -1 times negative the polynomial. But again, that doesn't do squat for us. You know, it's useless. So that's why they're trivial factorizations. But if that's the only way to factor, then we say the polynomial is irreducible. Okay. In fact, we have this. A trinomial like this, if there are no factors of a times c that add up to b, then this trinomial is irreducible. In other words, if you try the methods we used in class and they don't apply, they don't work, then it's irreducible. And here's some specific examples. You can have a sum of 2 squares, ax squared plus b squared. That's always irreducible, assuming a and b are not 0. And a and b have no common factors besides 1. So these are always irreducible. In particular, if we take a to be 1, these polynomials are irreducible. X squared plus b squared, x plus d and x minus d, where d is any number. I mean, here I want b to be non-zero, but here d could be anything. Those are going to be irreducible. You can't factor them down any further. It's just vocabulary. I think that's good to know. That's all. And we also have these words. This was from the previous slide. Okay. That should be a D. Let me fix that. Actually, forgot to take this off. Let me just cross that out. Okay. Left it there. I forgot to take it off. Sorry about that. A polynomial is reducible if it's not irreducible. Okay. Actually, you know what? Let me do this. There we go. I fixed that.